Thanks. Thank you, Rob. I'm going to start us off explaining a little bit about DNS, how it relates to the internet, how it relates to security, and what passive DNS looks like. And then we have, in my opinion, a much more important story from Gene about applications and results rather than capabilities. So let me do the boring part first. So the thing about DNS that surprises folks is it's getting bigger, but it's looking smaller. We used to have to type in domain names off of business cards or off of billboards that we had seen, and that's not happening as much anymore. Most growth of internet endpoints is mobile, and typing domain names on a mobile device is hard. And so the industry has trended toward clicking on something, searching for something, clicking on a link somewhere, so that you're accessing content more and more by replying to email or clicking on something somewhere and not seeing the domain name, not having to experience the domain name. And that's different from even 10 years ago. And that makes people perhaps think that DNS is less important or less used. That is not the case. DNS is growing amazingly well. It is more important than ever. And every one of those links that you click on, everything that you can search for, everything you can reply to, is because the internet is linked together with pointers to other domain names. So that's a difference between the lived experience and the actual sort of true red pill experience. I'll give you some metrics. First, I should explain what a delegation point is. People often call them domains, but anything you can look up in the DNS is a domain. So let me be very specific. A delegation point is something you can buy from GoDaddy. Example.com is a delegation point because the person who owns that name is different from the person who owns the name above it, which is .com. www.example.com is not a delegation point. That is a fully qualified domain name. And I want you to bear that distinction in mind as I explain that there are about 150,000 delegation points created every day. And because there are 86,000 seconds in that day, that means we call it an average of 2 per second. That's the aggregate creation rate of domain names, of delegation points. Most of them don't live very long because most of them are created for malicious or annoying purposes and they get taken down or abandoned or black-holed or whatever. About 60 fully qualified names are created every second. And about 600 changes occur every second, where it used to be that the A record for www.example.com pointed at one thing, and now it points at something else. So keep those metrics in mind. That happens all day, every day. We are seeing constant growth in DNS and constant churn in the content of DNS. So what I've shown on this slide is a simple 3-layer hierarchy showing your smartphones at the bottom as a stub resolver, communicating with a recursive name server, which, if you're on the Wi-Fi here, was provided to you by SANS, but if you're at home, it's probably provided by you or your ISP. If you're at work, probably came from your IT department. That recursive name server is the heart of complexity in DNS. It is where everybody goes to look stuff up, and if it knows the answer, it will answer from cache. That's how DNS has been able to grow from humble academic origins up until today, where we have billions of people depending on it. If it doesn't know the answer, the recursive server will have to go ask a content or authority server. And that's it. I've just told you how DNS works. Anybody who says it's more complicated than that is missing the point. What you're seeing over on the right is the Farsight Security Information Exchange, but really any passive DNS provider has to get their data from somewhere. We choose to get it above the recursive server because it's our belief that internet users have a reasonable expectation of privacy, and there's a whole lot of PII, personally identifiable information, below the recursive because you know the IP address of the person who asked the question and you know what question they asked, and so you know what kind of criminal they are, if they are one, and you also know the popularity of names and so forth. So that's surveillance. I don't do surveillance. So we collect above, where all you see is the cache miss traffic that has server IP addresses. In my opinion, there's no PII there. And various university and ISP lawyers who operate sensors for us have agreed with that perspective. We take the data and roll it down this waterfall. We take 200,000 cache misses per second, run them through various real-time channels. You see a deduplicator here that has an 800 gigabyte hash table and 24 of the fastest cores most expensive at least, cores that you can buy, in order to turn that 200,000 events per second into closer to, I don't know, 15,000 per second, which are then subsequently filtered down because there's a huge amount of junk that goes through DNS that you wouldn't want in a database. It has no security importance. If it does have security importance, we put it into a real-time channel called 2 of 6. That's the bit bucket hanging under the combine that gets all the chaff. And a few security companies get nothing but 206. We have nothing else they care about, but they love to see the junk. That's fine. Ultimately, the output of this goes into a database that you can do lookups on. Here's an example of me doing a lookup on my old vanity domain. I sold it, and here you can tell exactly when I listed it for sale, because historically speaking, I used to have one set of NS records. Now I have a different set. And now today it would be an even different set because it's being used to sell Vixes, whatever that is. Here's an example of iteration. Traditional DNS, you can't ask a wildcard question. There are wildcards, but only at the answer level. In passive DNS, you can say, what are all the names that match this pattern? And that's kind of cool. If Vix.com was a criminal, then you could imagine how you might get a list of all their related assets and figure out how they're using them or how they might use them and how you might defend yourself against them. I grepped it down to just my Comcast business link because there's so much other crap in my domain. Here's an indication of right-hand side lookup. Traditional DNS, you can only do a left-hand side lookup, but here I said, show me all the things that are MXing through this server. And in this case, it was because I had lost my postfix config and I needed to know what domains I should be answering email for. So this was not a security use, this was an auditing use. Here you see what the FBI's public presence looks like, very clean. I didn't show the dates in this example because it has never changed. We've been recording this since 2010 and it's been quite stable. But I have some friends in the FBI and I wanted to either congratulate them or not. It turned out not, because they didn't realize that by putting a whole bunch of other things into the same /24 address block, they were exposing what other projects they had. InfraGard is supposed to be spelled with just an A and no U, so there were hundreds of actual InfraGard chapters, and then the InfraGard with a U was, I guess, bought for typo squatting purposes or prevention. But anyway, again, if you're a criminal and you place related assets in the same address block, passive DNS will tell you, will tell the security researchers who are following you exactly what you own. And that is pretty cool stuff. It's magic when you first get your hands on it. I do want to emphasize, I like that dig format that I've been showing you, because I used to be a DNS guy, but it's terrible to program for. So the server is actually returning JSON blobs, which my tool in that example has been converting to dig. So let me just say, before we move on to the real part of this, which has to do with results, not capabilities, passive DNS is getting very popular. I am one provider, but I know of 5 others. The particular JSON schema that that we developed is now used by all of them, so that if you are a client of one and you wish to become a client of the other, it's because we wrote an internet RFC describing our schema, and then everybody who followed us followed the same schema. So this is not intended to be a product placement issue. I'm just using our system as an example because I have an API key for it. So, turning it over to Gene.
We're good? Okay. Hi, everybody. Thanks for having me. I'm Gene Stevens. I'm the CTO, co-founder of ProtectWise. And what I'm going to do is show you how we're able to leverage this passive DNS functionality to do a fast hunt and pivot. So we're going to go from a DNS into full forensic packet analysis back in time. So just as a little setup, just context of like how this works, and you can imagine how this kind of intel can be fed into the system. What ProtectWise basically does is that we have these software sensors we give to our customers, and they put them anywhere in the network. You can see some examples here. Industrial control, by the way, that's pretty cool these days. That's a lot of fun to work on. But what they do is they do packet capture at great scale, and they stream it to the cloud. We run it through a bunch of different detection capabilities. We also store a copy of all that data. And if you're doing the math real fast right here, you're realizing it's a monstrous amount of data, and it absolutely is. But what we do with it actually is that we run it through a suite of threat detection capabilities, and so that's signatures and heuristics, a bunch of ML classifiers, behavioral analytics, that kind of stuff. It's a suite of different things. So Farsight feeds into that, right? So that's something that we consume. We pull those APIs, we drink from that fire hose, and kind of feed it in the system. Is coming in, thousands and thousands of times a day, and it gets turned on in real time, which is cool. So people can actually get that real-time analytics across even really disparate infrastructure. But what's also really interesting, and we're going to dig into this a little bit, is that as that intel comes into the system, it serves as like an indicator, a trigger. It tells us what to look for in the past. So what our software does is it takes that intel, and then it does packet analysis. It kind of rewinds the tape, right? Just like in a bank, you wouldn't just be satisfied with logs of who went in and out the doors. You want cameras recording, right? On all the time, so you can go back to them to ask them new questions. And we're going to do that. We're going to use passive DNS, we're going to go back in time, look at past network history, and we're going to find something interesting. This is going to be a simple example. It's going to be easy to follow. But show you how easy kind of hunting is when you leverage this kind of intelligence. DNS is super powerful. So let's go back in time. So before I get into the meat of this, I do want to give credit to the guys on video who were in ProtectWise who did the actual work on this. I'm just on stage on their behalf. So thank you, James Condon and Thomas Hagel. If you guys are watching this later, thank you very much for your work. So back in December 2015, there's an alarm that fires about a compromised host is beaconing. This is a Cardoso group. It's a known beaconing structure. We see this. It's kind of easy to identify, not super sexy all by itself. But what's interesting is that we see this communication, right? So we tie in the DNS intelligence. So we look at this ACME. We see this IP address, so one IP address. Okay, that's interesting. So we know what this is related to. And then we're going to execute some forensic analysis on the packets. Okay, so initial indicator's been discovered. What we do is we reach out to DNSDB query, and our software is very highly automated. I'm showing you manually what it would look like off of the command line. You say, okay, so what else do we know about this host? Well, there's a whole suite of IP addresses. Initially, there were 3, and then there were 5, and so we were able to actually revisit this a couple of different times. But you look in here, we see these 5 different IP addresses. You look at the second one from the bottom, you're going to see first seen 2015 8/20, so many months prior to this actual detection firing, right? So that's interesting. So we take that data and we look back inside that same customer, and so this is kind of a high-level summary, but we hunt inside that customer and say, let's take all those IP addresses and let's find every single network flow that has communicated over that space, and we have a copy of this data that goes back, months and years. And so we're able to go back into that, buried in that petabytes of data, right? That huge haystack are these flows. So we find them hidden, and we find connections to those hosts going back to July 15th, 2015. Let's see if I can go back one slide, because I'm going to look at something. Look at the intel. It says 2015 8/20, right? So we're seeing communications going back to that same IP address. Maybe it's a different domain back then, but we're going to analyze it anyway. We're going to use this. This is the indicators telling us where to look, right? So we're going to hit, we're going to land, we're going to kind of expand through the data set. And so we see packet level forensics. Basically, we pull down those packets, we look at them, and we see there's successful HTTP communication going on. So we see the back and the forth. The firewall's not blocking this, nothing's going on, right? There's there's active activity, and we see nearly half a year prior fully established APT activity trafficking through that data set. And so then we dig in, and this is a kind of a Wireshark type screenshot you're seeing here, but you can see the packets. Probably a little hard to read some of this, but we go in there, and then this is the point at which we're saying there's some interesting payloads in the middle of this. We pull those out, look at them, and you can just kind of sight read some of this stuff, right? You look at it and say, oh, clearly base 64 encoded, so let's take a look at that, let's decode that, and look inside the file. It's like, it turns out it's just really simple XOR. So, you're looking at it saying, there's some repeating patterns here at the top of the file. I bet you those are, zero value bytes or something like that. So we XOR them, and sure enough, the whole thing flips, which is kind of fun that they made it kind of easy for us. But we're looking at this, and this is different than the actual detection that we had initially that started this whole thing. So that boost DOM, or I guess we don't actually have a name for that, that backdoor. But anyway, that one sends a signal. We hit Farsight. Farsight says, here's the potential impact on this. We follow that Farsight, that passive DNS data, and it's producing results. We're finding stuff in there. So we're seeing these PEs. We're able to actually get this thing deobfuscated, and there you can see the little DOS stub, right? And so we've successfully identified it. We can tell what it's doing. We can statically classify it, that kind of stuff, right? And so the real moral of the story here is that in terms of investigative analysis, we're able to take this and go deep into this customer's haystack and validate this across that customer's experience. And that goes back like 6 months of packet storage. So that was pretty cool. Also, one key element of that was like how fast this can be, because all that stuff you can automate, right? We had to do a little bit of manual discovery, but our analysts sat there and we were like, I've just got a bunch of little binaries. I'm going to see if I can unpack some of this stuff, right? Made the work really easy. It's very, very automated and instantaneous. But what's interesting as well is that what ProtectWise does, also as an automated service, is we take those same indicators, we take, write the heuristics, we write other items that describe their general behavior, and then we apply it across the entire customer base. So now we have a bunch of customers that have these massive data sets. We're finding a hit and following it through in one customer's haystack. We don't have the same hit in other customers' haystacks, but we were able to discover this file that existed, and then we're able to actually automatically go through all the other customers. I'm kind of giving you a summary here. Hunt, NetFlow, customers all. We're able to find latent infrastructure in other people's networks that was not detectable in a real-time system. There's no signatures, there's nothing that could describe it at the time, but we were able to actually go back using passive DNS, and it told us where else we could find this file that would only via passive DNS discoverable in this one network. Just happened to be, that was just a delivery, the weaponization, that backdoor was targeted against them, it was successful. The delivery mechanism in other people's networks may have looked very differently, but we're able to actually identify that. So we're able to look at and identify those machines, get them fully, help our customers get them fully mitigated, and we're able to look at the domain resolution for all those customers, right? So how were they communicating, what was going on in there, go back to Farsight again, expand, and just kind of can kind of fold over that list, and next thing you know, you've got actually strong validation at a very solid and performant packet level analysis. So the conclusion to this, and it looks like we are ahead of time on this, which is good, is that we're able to use Farsight DNSDB, passive DNS, powerful concept, and use automated retrospective analysis, strong packet level validation to discover effectively the previously unknown inside our customers' networks. So the hunt is actually really powerful, and it's actually really simple. You could put this in a Python script and it will execute. Okay, we are at the end.
Questions?
I have an observation while we wait for the microphone to settle. Just as there are many passive DNS databases that you could choose from, there are also other stored data indicating prior results. So if you're saving syslogs, these same tricks work there. It's of course very powerful to do it with NetFlow and PCAP and so forth, but whatever you're storing that shows historical activity on your network can be used to hopscotch through history and find the relationships and map out your adversary's infrastructure.
So you were talking about the going back through your recursive or retrospective packet search. What's the volume of data you're collecting there, and what's your attention time?
So the volume of data is petabytes for even modest customers. A year of storage of gigabits a second, you get in a petabyte range pretty fast, right? So in terms of like how we actually execute that, like our specific approach is that we do very targeted packet capture for subsets of the network that are super valuable from a security perspective, like YouTube videos, Netflix videos, that kind of stuff, not super valuable, right? DNS data, not just the intel, the bytes, super valuable, right? So very much targeted around that subset of the network traffic that we really want to analyze, but it's kind of greedy in that sense because we want to capture like all the HTTP that we don't feel safe in actively filtering out because we want to go back to it and ask it brand new questions, right? So there's HTTP traffic that we stored that, as far as we knew at the time, wasn't super valuable. But then 6 months later, turns out it was super important and the impact was significant. Does that answer that question? Or was there another part to that? Okay. Oh, and how fast, did you ask?
Yeah, like
total volume of traffic? Yeah. Like that feeds into our platform or is many gigabits per second? Depends on the size of the organization. We're mostly large enterprise, so very, very large networks.
Hi there. I have a question concerning discoverability. Do you see any issues with the fact that these data stores might become part of a legal action and become a source for lawyers to request as part of legal action?
Yeah, it's a valuable haystack, right? So that's all about making sure our customers control our access to it, independent access, right size visibility. You can store and analyze only what you want. Could be everything, could be just a subset, few assets, few hosts, different apps and protocols.
So let me follow up by saying the telcos learned a long time ago with call detail records that the best way to not have to answer a subpoena is to not store the data for a terrifically long period. We riffed off of that by simply saying, if we don't collect any PII, there will never be a subpoena toward us because we would be useless. And so being deliberately useless for that type of thing is another answer.
All right, that's all we have time for. Big round of applause for Dr. Vixie and Gene.